The universe is not sitting still. Right now, in the dark between galaxies, forces we cannot see are tearing structures apart. The cosmic web writhes, voids empty further. And the biggest piece of the puzzle, the 95% we cannot touch, is only now beginning to reveal its shape. This is a journey past everything we can see, into everything we know is there but cannot observe directly. We will move from the familiar dimensions of our solar system outward, through the architecture that holds the universe together. We will pass through regions so vast and so empty they have no analog in ordinary experience. And at the furthest limit of what our best instruments can reach, we will find something our current physics cannot yet explain. Start here, not with a diagram, not with a textbook figure, just you, standing on the ground. The planet beneath your feet is roughly 8,000 miles across. The horizon sits about 3 miles away. This is the largest thing most human beings will ever physically touch. Now step back. The distance from Earth to the Sun, 93 million miles, is so vast that if you tried to drive it at highway speed, the trip would take over 170 years. And the Sun is our nearest star. The next nearest, Proxima Centauri, sits 4.2 light-years away. That number sounds small until you realize a single light-year is nearly 6 trillion miles. The distance to our closest neighbor is not a number your brain can hold. It collapses into something abstract, something that does not quite land. But we are not even close to the edge yet. The Milky Way stretches roughly 100,000 light-years from one side to the other. If you shrank the entire solar system to the size of a quarter, the Milky Way would still be larger than the continental United States. And the Milky Way is not large, it is ordinary, middling even. The observable universe, everything we can possibly detect, has a diameter of roughly 93 billion light-years. On that stage, the Milky Way is not a grain of sand. It is a single atom in a beach that stretches past every horizon you can imagine. At the largest scales, matter does not scatter randomly. It gathers into a network called the cosmic web. Dense clusters of galaxies linked by long filaments and sheets, with enormous near-empty voids in the spaces between. Picture the inside of a sponge, scaled up by a factor that makes the word vast feel like an insult. The filaments hold the galaxies. The gaps hold almost nothing. Those gaps have a name: cosmic voids. The Boötes Void, sometimes called the Great Nothing, spans 330 million light-years in diameter. It contains just 60 galaxies, when roughly 2,000 were expected for a region of that size. Voids like this make up around 80% of the observable universe's volume. All of that visible architecture, the filaments, the clusters, the superclusters, is crammed into the remaining fraction, like foam clinging to the walls of an enormous dark room. That alone should unsettle you. But here is the part that changes everything. Everything we just described. The filaments, the galaxy clusters, the Milky Way, every star ever catalogued, every planet, every atom of everything ever observed by any instrument humanity has ever built. That is 5% of the universe. 5%. The next 27% is dark matter, a form of matter that neither emits nor reflects light. We cannot see it directly. We only infer its presence through the gravitational pull it exerts on the visible things around it, like noticing a wind you cannot feel by watching the trees bend. Dark energy makes up the remaining 68%. It appears to be woven into the vacuum of space itself, distributed evenly, not diluted as the universe expands. Every map we have ever drawn of the cosmos is a map of the shadow, not the thing casting it. Gamma-ray bursts are the most violent event the universe is capable of producing. In a few seconds, a single burst can emit more energy than the sun will produce over its entire 10 billion year life. Not more energy than the sun emits in a year, not in a century, in its entire existence. 10 billion years of nuclear fusion, of hydrogen burning into helium, of light pouring into the void. All of it, matched and surpassed in the time it takes you to tie your shoes. Rather than exploding in all directions, gamma-ray bursts channel their energy into two narrow beams, like a lighthouse powered by the death of a star. A lighthouse that, if it swept across your solar system, would vaporize anything caught within 200 light-years of that beam. And these events happen somewhere in the observable universe roughly once per day. We only catch a fraction of them, because most of the beams are aimed somewhere else entirely. The universe is firing at things we will never see, but gamma-ray bursts belong to the visible 5%. They are the loudest things we can see. They are still not the strangest. Consider magnetars. A magnetar is what remains when a massive star collapses, a city-sized neutron star so dense that a single teaspoon of its material would weigh more than 1 billion tons. But the magnetic field is where physics stops making sense on any human scale. At a distance halfway from Earth to the Moon, a magnetar could wipe the magnetic information from every credit card on the planet simultaneously. From roughly 120,000 miles away, within a field of that strength, X-ray photons split in two or merge together. The vacuum itself becomes polarized. Atoms are deformed into long cylinders thinner than the quantum relativistic wavelength of an electron. The atoms in your body, the ones that define your shape, your chemistry, your existence, would be physically restructured by proximity to one of these objects. Space is not a backdrop. It is an active environment full of things that would unmake you in ways that have no analog in ordinary experience. Now the picture sharpens into something that genuinely unsettles. We started with the skeleton, the dark matter scaffolding that makes up 27% of everything, invisible to every instrument we have ever built. We noted that the visible universe, the 5% we can actually observe, is crammed into the filaments of the cosmic web. And the James Webb Space Telescope is now staring into those filaments at distances so extreme that the light it collects left its source before the Milky Way existed. Some of those ancient galaxies are already dead. Fully formed, star formation complete, silent, sitting at a point in cosmic history when, according to our best models of how structure grows, they should not yet have had time to become what they are. The universe apparently built enormous, complex, mature galaxies faster than our physics says it could. We do not know how. We do not know why. Every time Webb looks further back, the timeline gets more crowded with things that should not be there yet. Think of it like this. You walk into a forest and find fully grown oak trees where your models said there should only be saplings, in soil, that by every measurement has only existed for a fraction of the time an oak tree needs to reach that height. You are not looking at a broken tree. You are looking at a broken understanding of how trees grow. And that is the payoff. Not a solved mystery, not a tidy answer at the end of a long journey outward through scale and violence and strangeness. The payoff is that the question got bigger. Every instrument we have ever built was supposed to bring the universe into focus. And JWST, the sharpest eye humanity has ever opened, is returning images that make the picture less settled, not more. The universe is not a mystery we are in the process of solving. It is a mystery that expands every time we look directly at it, and we have barely started to look. Subscribe to Cosmos and hit the bell so you never miss what we uncover next. Watch the next video on your screen right now and grab your free guidebook from the description below.